It's because of the location of the receiver and the speaker and where I stand, and it just picks up interference. So, which is why it would be much better if the speakers were in the back of the room. And then, well, no, because I can, all I want to do, I don't need to be louder. I just want to be able to record it so I can hear it again later. You know? Waste nothing, we're explaining the science of sound. Alright, this is wasting time. So number one, explain whether it's linear or not. How do we check C? What kind? We look for the difference. We get minus 3. So is that linear? Yes. Alright, we look at B. We have minus 3. So this is not linear, so what could we do? We could find the second difference, so from negative 3 to negative 1 is? Plus 2. So that would be quadratic. Alright, graph the data in item 1B. Okay. So make yourselves a little grid. 0, 5. 1, 2. 2, 1. 3, 2. And 4, 5. Okay, so we get our... Alright. So what is our minimum?
2, 1.
Texan way? What do you say? Parabola. Or if you listen to enough Tool, you start calling it parabola. Alright. Do we have enough information, or could we come up with an equation for this line?
Yes. No.
We could work towards it. Why not? So let's say, what if we start with x squared? Okay. So then if we try 0 squared is 0. So what would we need over here? Has to equal 5. So what could we add to that? Plus 2x? Plus 3. Will that work? Because what's 2 times 0? 0. So plus 5. So that works for the first one. Will it work for the next one? Well, let's try the next one. So if we say x squared, so 1 times 1 is 1. But we want it to equal 2. Dose. So plus x plus 0 plus 1 plus nothing. Make up your mind. Will either of them work? Because it still would need to work for this first one, right? Yes. So the answer is no. Well, what we were right on is this plus 5, right? Because we think when both these, knock it off, okay? When both of these, when x is 0, the only thing we have left is this constant. And so since we have this point 0, 5, this has to be 5. So really what it's going to come down to is, what is this? Who in the heck did that? What is this middle term? Yes, Ian's so very proud of himself.
Wait, that wasn't me though.
And his little buddy. Okay? So we need to find that middle term. So if we think, do we have an axis symmetry here?
Yes.
At where?
2, 1.
At, at x equals 2. Right? Because that's our minimum, which is our vertex. So the x value of that has to be our axis symmetry. Which means that negative b divided by 2a equals 2. Right? Because we said negative b over 2a always equals our axis symmetry.
Is that just to find x?
Okay? So if we assume
What numbers do we put in?
x is, or a is 1, right? Hopefully. So we have negative b over 2, whoops.
How do we find? It doesn't have to be negative.
So what would b have to be to make that statement true?
Negative. 4. Negative 4.
Negative 4?
No. Positive 4. No, negative 4. Oh, yeah, it has to be negative 4.
Negative 4? So what if we try that?
Negative 4.
So will that work when x is 1?
Yes. Yep.
Because we have 1 minus 4 is negative 3 plus 5 is 2. Hey. What about the next one?
It works. Oh, we just,
So it'd be 2 squared.
minus 5x plus 4.
What? we can't change this. This is what we want to stay the same. But will it work when x is 2?
Maybe. Yes, it will.
So 2 squared is
4.
minus 8 is
Negative 4.
negative 4 plus 5 is
1.
Big yield.
So it does work?
seems to.
We made a rule.
Okay. Well, that was totally not the question and something that we'll deal with later. But hey, we figured it out. Yay, math. All right, next one. Can you have a pencil? You should have your own pencil. It broke. I have keys. You on my car?
What kind of car? Is it like the...
Here, I got you a pencil.
Whoa.
All right, identify the function as quadratic. So is a quadratic? No, why not? This is what? This is linear. How about 6x squared? Yes. And how about no? How could we rewrite this without the fractions?
Flip the fraction. 6 divided by x.
So this would be 6 what?
Divided by x.
Not without the fraction.
Times negative x.
Why can't we use the
No,
symbol?
times.
So 6x to the what power?
Negative 2.
Negative 2.
Wait, why can't we...
Remember what we talked about? 1 over x is the same as x to the negative first. Same way we said x to the negative third power is the same as 1 over. So if you ever need to flip the sign of an exponent, you move it to the other side of the fraction and change the sign.
So if it's negative squared, would that be quadratic?
No. To be quadratic, it has to be exactly positive 2. This degree is negative 2. That's, I almost want to say not nothing. But it'd be something. You can graph that. Go ahead, graph it. See what you get.
Why can't we use division symbols?
No, my house. Did your house break down?
Said it's still here.
It's not there.
Not very reassuring. because I don't have swipe anymore in this. The autocorrect on this phone is terrible. But
I'm zooming out. How do you zoom out? You don't zoom out, you just zoom this.
alright, does anyone have a pencil for Ian? Because Ian lost his pencil.
I went to zoom to fit, it went to error.
Okay. Should look pretty funky. Like an upside down cheese? T? Sure. Alright, moving on. So, alright, so number 4. Write each function in standard form. So, standard form y, ax squared. So for a, we just have to rearrange it. So y is x squared minus 2x plus 5. B, all you have to do is move the x over. For this one, you just move that over. And the last one, how can we get rid of divided by 2?
Multiply by 2.
Well, I say that, but that doesn't really work because then you'd have 2 times Lx to get rid of that. But since we want y by itself, we can't really do that. So we say, can we divide each of our terms by 2?
Yes.
So 2x divided by 2 is just x. And 5x squared divided by 2?
2.5x.
Well, you could say 2.5. And you could even leave that as y is 5/2 x squared. Okay?
So, times?
Nope. That's it. All right? What's confusing you?
I don't know, you went too fast.
Well, maybe you need to listen quicker. Complete the tables. So if x is negative 3, fx would be, well, this would be 9 minus 6 plus 3. 6. When x is negative 2, we'd have 4 minus 4 plus 3. At negative 1, we'd have 1 minus 2 plus 3. At 0. And if we see it start to repeat, what should we get at 1 without even having to work it out? 6. Okay. So this is 6. All right, the second one, a little bit more complicated because now it's all negative, and So what we could actually do here, what could we do? Could we factor out the negative? Could we say this is negative x squared plus 4x plus 3? And then just work it out like it's positive and then take our final answer and just flip the sign. And that might make things easier, especially for those of you who are like, oh, negative x squared, that's so confusing because you have to square it and then the sign changes anyway. I don't want to do that. You could always just factor out the negative and not worry about it till the very end. Okay, I told you that since we started factoring, you factor out the negative if it's x squared. Remember? I can't hold your hand forever. Math's all about finding the simplest way to do things and then doing it that way. Because if I teach you the easy way, and then you're like, oh, I don't want to do it like that. But if I show you a more complicated way, and then even better is when you figure it out on your own, and then you're like, okay, I found this way. I'm not going to tell anyone else. It's going to be my secret. But I'm totally going to be able to do my work easier than everyone else. Ha ha ha, peasants. Right? And then when we finally tell everyone else and you're sitting there like, ha ha ha, excellent. I knew about this all along. Okay. So, negative 4 squared. 16. 4 times negative 4. Negative 16 plus 3. So this works out to 3, and then we make it flip the sign. Okay? All right. Well, that's what it should be. Next one. Negative 3 squared. 9 minus
12.
So that gives us 0. That's good. All right, negative 2 squared.
4.
Minus.
Negative 1. Right? No. Right? Yeah.
Wait.
No, it's positive 1. That's positive 1.
All right, because it would be negative 1, but then remember we flip the sign at the end.
I got it right.
Okay, you don't have to tell me every time you get one right. All right, negative 1 squared.
1, yeah, right?
Minus
4.
4. Also, if you notice,
There's a pattern.
there's like patterns here because we're going one number at a time, so all these are going to change by.
Minus 4.
So this does work out to,
Minus 4. 0.
this is 0.
Wait, how is it 0?
What's 1 minus 4?
1 minus 4 negative 3.
Okay, what's negative 3 plus 3?
Oh, 3.
Okay.
Negative 3 plus 3. 3.
And the easy one, if x equals 0, y is negative 3. Why don't we have to work that one out?
Oh, there's another pattern.
Well, not even that. Because if it's 0, x squared cancels out. 4x cancels out. All you're going to be left with is the constant.
But doesn't it flip and become positive?
No.
Then why didn't we just
Oh my goodness. 0 plus 0 plus 3.
Oh, never mind.
Yeah, and then you're like, oh, why'd you show us this other way? This is more complicated now. Going back to doing it the hard way. All right, then graph it. All right, I guess we can graph stuff. Both of these are parabolas because they're quadratic, so negative 3, 6, negative 2, 3, negative 1, 2, 0, 3. Wait, what? Oh, yeah. Yeah, because that's A. That's why I put it. Then we have -4, -3. Should be right about here. -3, 0. -2, 1. -1. I'm messing this up. I know. I'm not really messing up. I'm just, it's not as nice as I'd like it to be. -1, 0, and 0. That still could be better, but you get the idea. Alright. So hopefully we're at that point where we can graph stuff without having to make all the individual little lines and everything. Because really, does it matter exactly where this is? No, it's just that we have an idea where it, because really the important points that matter are your zeros, your vertex, and maybe this y-intercept. So if you have an idea of where all those points are, you're going to be okay. Okay, you also have a calculator that'll do it more accurately. Who needs R's? Whatever, lodger. No, lodgel. Lodgel Malin. All right. Okay, find the maximum or minimum values. So what does A have? Does A have a maximum or a minimum? Minimum. Where is it? -1, 2. Is right here. Okay, how about B?
-2, 1.
And that is the maximum. Isn't that convenient that it happens to be the middle one? All right. How did we know this was going to have a minimum even before we graphed it? Because it opens up. How could we have known it was going to open up without even graphing it? Because A is positive. How about B? We knew that was going to have a maximum because it opens down because A is negative. Well, we got that part. All right. Was that it? What did number 7 say?
Wait, we didn't do 6.
Characteristic of the graph of a quadratic function distinguished it from that of a linear function.
All right, so what's the big difference between a linear and a quadratic function?
Quadratic function goes 2 times the square. Quadratic function.
This is the difference. I feel like this should be on like the top of one of those big pyramids. You know? And then it should have all these people like offering their sacrifices to the well, because it's x squared, so 2.
Put an X on the other side.
Actually, you know what? For this to be a proper actually, I was thinking more to make this a proper setting for our x squared. This should actually be a
Parabola.
because it's a parabola.
They'll slip.
And stairs. We need some fireworks saying I'm more X squared.
All right.
Instead of a hill, it's a rainbow. You should be able to make animation. Yay.
All right, number 1. So we're on the next page. Almost new stuff, kind of old stuff. Complete the table for y equals x squared and graph it. So we've done this. It's not so bad. So -3 squared is
9.
-2 squared.
4.
4. 1, 0. 1, 4. Okay, then we graph it. It's nice of us to give us enough space. It's almost like they knew what we were going to do.
I think they do.
Why do you think this is called a parent function? It's not because it's the biggest.
It's the mother of all. It's the mothership.
Okay,
It's the mother of
so,
all.
alright, so I'm willing to go with because it's the mother, but why? Because it's just x squared. So it's the most basic, it's what every other quadratic function relates back to. So it's the simplest, most friendly. Look how friendly it is. It's
It looks like he's like one of those people that goes down.
okay, cool.
He's depressed inside.
All right, using mathematical vocabulary, describe this graph.
It is very, very the mother of all ginormous.
All right, that's my word. What else? All right, you have to use more math words. Describe what's happening here. Okay. Has a minimum. Positive A. What does that mean when it has positive? Because it's just saying describe the graph.
What's a minimum?
Has a minimum. So what does it mean when A is positive? We say the graph opens upwards.
It has
1, 0. That's a good one. Because there's only one place where y equals 0.
It's nose and eyes.
Axis of
symmetry is on the y-axis.
all right, that's pretty good. Oh, there's question 7. All right, complete second and third columns for y equals x squared. So we said when x is -3, this was 9, 4, 1, 0, 1, 4, 9. So what is the first difference? How do we get from 9 to 4? What? How do we get from 4 to 1? What? From 4 to 1. -3. These people are like -2. Like 4 minus 2 is obviously 1. Duh. Okay, how do we get from 1 to 0? Subtract 1. All right. We've now answered one question in a row. All right. Here's the tricky one. How do we get from 0 to 1?
Oh my god, add 1.
Plus 1.
Oh my god, I knew it.
Wait, what?
All right. How do we get from 1 to 4? Plus 3. Oh, answering streak up in here. Okay, dude, the difference.
No, wait, but when they make difference of like 0 to 0.
He thought it was from 2 to 4. How do you get from 2 to 4?
No.
1 to 1.
And even if you did that, that answer still wouldn't have been. What'd you say? 2? All right, how about from 4 to 9? From 4 to 9.
3. Oh, wait, no.
Plus 5.
X plus 1.
And you've got some people in here be like, really? This is what we're doing?
Where's all the people? Where's all those?
And then you have some people who knew the whole thing the whole time, and they're just sitting there like, they really are peasants.
I thought you were doing like X and Y.
All right. So now we go to the second difference. How do we get from plus 2 from -3 to -1? Okay.
Wait, so why are you putting the little dashes?
Because there's no difference to find here. There's no number there. So we start there. Okay. All right. That was fun. Label the fourth column as second differences. Oh, we already did this. What do you notice about the values? All right. So that's how we tell it's quadratic. We should know that already. No. Why would it be a half day? No, spring break is next week. Which is like the least sense thing anyone ever said. It's like, why do we have to do work on the Friday if we have to have a whole week off next week? We should get that extra day off. That's good. Well, it works better if you actually saw a tree go. All right. I have been recording this whole time. So everyone's going to get to see Antonio Mahul not quite knowing how to get from, what was it? From 4 to 1.
I said +3 before.
All right. Number 5. So now we're going to see what happens as some of our values change. So what is the difference between y equals x squared and x squared plus 3?
It's just gonna add 3.
But what is the difference as far as our standard form of? This time we have a c. So what do you think is going to happen to our graph?
The c is just gonna add to it.
Going to add to it how? How will the graph change, you think?
It will just move a little bit. Yeah, I'll move it.
Well, put off to the side where you have notes.
It'll be wider.
Make your hypothesis about how you think the two graphs will compare to each other. So, because we're going to graph y equals x squared again, and then we're going to do x squared plus 3. You're going to put them both in the same grid, and we're going to look to see how they are similar, how they're different. So write down something you think, how they're going to relate. What? Oh, fine. I should start taking restroom breaks. Be like BRB. Can we not leave stuff on my floor?
Not me.
Not you? Who else is doing this? This is the only class I've had in here. You're the only two guys sitting in the front row.
Why would I have a pencil? Why would I have one pencil?
Then whose stuff is this?
No, pick it up.
Alright, so we have our hypotheses. What's the plural to hypothesis? Hypotheses. Okay. Hypothesize is, I think, the verb. What? You think so? All right. Okay, so take a minute, fill in the chart, and while you do that, we'll look up stuff. Yeah.
There's a myth. There's this thing that says left-handed
Hey.
people use more of their motor control. Left-handed people have more.
They have shorter lives.
Plural.
Hey, did you know that left-handed people prefer quietness?
Hypothesis.
Look how quiet he is.
Hypothesis.
All right. Shh.
Hypotheses.
All right.
I thought it was with an eye.
And yet, there you go.
Is that guy animated? Was that guy animated? Or was he just like naturally? It was Mr. Clean.
Okay.
Mr. Clean is animated.
I like how some people in the face of undoubtable proof are like, but wait, I thought it was this.
So, do I grab both of them?
How can the dictionary be wrong when I thought this? As a 7th grader, how can I be wrong? The entire foundation of my life shattered. Yes. All right, so 9, 4, 1, 0, 1, 4, 9. Over here, 9 plus 3 is 12. You guys just doing this on purpose now? Okay, good. 1 plus 3 is 4. We're on a roll now. Okay. Yes. Adventures in not knowing how to multiply or add. Jerry. So there's the first one, and that shouldn't look anything new. That's still just y equals x squared. That's the first graph we did.
Wait, so that's the 9, 4, 1, 0.
Yes, that's the one I underlined in purple.
Oh.
And then we have this one.
I think my hypothesis is right. I put it moved 3 units up.
Yeah, I put the vertex moves 3 units back. My hypothesis was right. Oh! What now?
Okay. Okay, good.
Look at this. Correct.
Good. All right. So we can say what happened here? Did our curve change? No, it's the same curve. If I were to move this, we see it's still going along the exact same path. It's just been, what's the word for that? Translated. Okay? So can we get an idea how does C affect our parabola? So C controls the vertex, how far up or down it goes. Okay? So that's part of, bless you. So that gives us part of our information. So now we know, looking at our equation, which way it's going to open. And we also know about how far up or down our vertex will be. What do we still not know? We still don't know how to move it left to right. Or what else? Well, no. How else can we change it? Some people Some people were saying that they made it their hypothesis. What were some other hypotheses we had? It'd be wider. So do we know yet how to make it wider or skinnier? No. So
Could it be like sideways? Like a C?
do we want to get into that? I guess.
Yeah.
Oh, okay.
How are we gonna make the Batman
It's
if we don't know how to make it?
this wouldn't be something you would do in algebra 1. It's something you do in algebra 2. Instead of saying y equals x squared, if you were to graph and that will make a more horizontal parabola.
How do we take the y out? How do we take x out?
So what would you have to do? If you wanted to still put that in terms of y, how can you get y by itself?
Y squared equals x.
How can you get y by itself from here? How do you get rid of squaring? If we take the square root of y squared, we'd get y. So what would we have to do with x? So what if you try y equals the square root of x? Remember we said it was I'm not sure if that'll actually work on your calculators. Does it give you? Oh yeah, because that'll only give you half because the other half of that wouldn't be real. Let me work that out tonight. I've never had to graph that because, heck, we barely get into algebra, not algebra 2. But that's the basic idea. You could do it on paper. You could make that chart of x equals y squared. What? You might try putting in, erasing the f of x and putting x equals y squared. I don't know if that'll work though. Yes, it will. Won't? Oh, well. I don't know. IDK. Alright, so if you have older brothers or sisters or parents who have fancy calculators, well, you have a question to ask them tonight. Alright, so if we have x squared and x squared minus 4, what do you think is going to be the difference in our... It should go down. Blah, blah, blah. And then it gives you the answer to that. We call those vertical translations. That's what we said. Because anytime we just slide the graph up and down, it's just a translation. How does value in C change the graph? We went over that. C changes if it goes up or down. So try these. So for tonight, and right now you've got a few minutes to start. Try these, and then number 9. Yeah, that'll be enough for one day. I'd like it if you got them right, but... And then hopefully you'll learn something from number 9. You'll have some information to bring home with you, to bring back with you. You should always have information to bring home. You should be like, as soon as you get home and you see your parents there, you should be like, flip the dinner table over and be like, let me tell you about what we did in math class today.
My dinner table weighs 500 pounds.
Well, then use your legs.
It's 500 pounds.
What? You can't squat 500 pounds?
I squat.
I thought you were in athletics.
No one can in this school.
Okay.